So our goal right now is to make sure that we have this equation equal to 0. So I have to move everything over to one side. It doesn't matter if it's the left or the right, but in my suggestion is to try to take the value that has the x squared and keep it positive. So what I would do then is subtract the 2x squared to both sides. So that'll move 2x over to the other side. And then at the same time, now you could do this because this is the way we've approached it. I'm not saying this is the exact way to do it because you don't need to do this, but I want to show you some kids move the 11 over and we get it set equal to 0. Because what we've tried to do in the past is we've tried to factor. Now, you might see one thing here, that I can divide all pieces by 2. And again, I want to emphasize this is not the only way to solve it, and you may approach it differently. But when I do that, I end up with x squared plus 12 equals 0. Now, the reason why I decided to do it this way was in Monday, we had an opportunity to try to factor this. And I'll just let you know, don't draw this part here, but if I plugged in, and the fact that it doesn't have a middle term, we could try to factor this by multiplying the corners. But you're going to know that this is not worth doing because 12 is not a perfect square number. And there aren't any factors of 12 that multiply together that add up to give me 0. So factoring does not work in this case, just so you're aware. So what does that mean? Well, technically you could have seen this already, but I really have one variable. I have x squared. So I could have just used regular algebra from the side. And if you did that, then you would go ahead and subtract 12 to both sides. So however you approached this, hopefully you ended up with this portion right at the bottom. X squared equals negative 12. And if you got there, you're in a really good spot. That's where we need to be right now. Now the interesting thing is what if we take our next approach and we take the square root? Well, if I take the square root of both sides, my calculator tells me that that's error. It says error, non-real answer, because we can't take the square root of a negative number. Well, today we're saying you can. So this is probably the new part here. And since it came up kind of organically, we're going to just show you how we would approach this. We're going to split up the square root of 12. So I'm going to take that and say, you know what, the square root of negative 12 is really the square root of negative 1 times the square root of positive 12. And why might we do that? Well, 12, we know how to break down. Right? Going back to geometry, we reduce the radical. 4 times 3 is the same as 12, so the square root of 4 times the square root of 3 is the same as the square root of 12. Now, we know a couple of things. I know that the square root of 4 is actually 2. I can't break down the square root of 3, so we're going to leave it. But what about the square root of negative 1? That's the imaginary part. That negative is what told our calculator there's an error, no real answer. But there is an imaginary answer. So today, anytime you see the square root of negative 1, that is going to turn into I. I stands for imaginary. And we'll talk more about why I put it right in between the 2 and the square root of 3. So if you ever look back on these notes, you're gonna see, you'll know exactly where this all came from. There's just one other thing we have to talk about. When I take the square root, we get two possible answers, a plus and a minus. So I fully understood and anticipated that you probably couldn't get past this part right here. Or if you did, you might have said error or no solution. And that's okay, because that's right where you're at. Well, now, look at the only new part today is right here. So hopefully you can look at that as we're doing all the things we've done before. And then the only new part is just dealing with this square root of a negative 1. Okay? All right. Nice little quote. Spring is a lovely reminder of how beautiful change can truly be. I also want you to think about that for this trimester, right? We're starting a brand new trimester. This is your chance, and a brand new topic. We're doing Algebra 2, so this is your chance to really have a fresh start from the beginning. So, what in the world did we just do? Well, we just learned about something called complex numbers. So these are the notes for today. We're actually going to cover two sections. 4.6 out of the textbook is on complex numbers. And that's all about what happens when I take the square root of a negative number. It turns into something we call I. I don't know if you want to, I mean, it's a sentence, you might as well write it down. But there are two forms that complex numbers can take. The complex number is made up of a real part plus an imaginary part. And it's written in the form of a plus bi, or it could be a minus bi, where the a and the b are kind of the real numbers, and I represents the imaginary unit. Okay, so where does this I, or this imaginary unit, actually come from? When we say I, that's what we're talking about. Well, what is I? We saw what I was. I is anytime you take the square root of a negative, well, anytime you have a negative number, we can pull out a factor of 1. And you'll see that develop throughout today. So what you need to know is whenever we pull out the square root of negative 1, that's actually equal to I. So I call that a fun fact because that's really how we're going to be using complex numbers throughout or basically the rest of the trimester. I have a little challenge for you, something to think about. If I know what I is, if I is equal to the square root of negative 1, what do you think I squared is equal to? 1. Close. Really close. So think about it. What happens if I square this side and then I square this side? What's left over? Cam, you were super close. So look at this. If I take negative 1 and I take I, that's our fun fact. Well, what happens if I square one side, I have to square the other side. So that means I squared is equal to, what happens with the square and square root? They cancel out, they go away. What's left over? Negative 1. So, that is another fun fact that you don't have to technically memorize, because if you know this fun fact, I is equal to the square root of -1, then you can generate that. But that does come up throughout today, so we just want you to be aware. Yep, Maddie, you're right. I forgot to check the chat. So, what does this mean, or how do we deal with this? The first part is just solving and getting used to where does this square root of -1 appear? And it usually appears whenever we take the square root of a negative number. So our goal right now is just to deal with the simplifying side. The nice thing is this is it's really one extra step past what we were doing in geometry. So if I have the square root of 24, what we want to do is we want to split this up as the square root of -1 and the square root of 24. Well, we already know what the square root of -1 is. That's going to turn into I. And then all that means is you just got to go back to the square root of 24 and break it down into the perfect square. So we're not going to spend a lot of time working through that. So I think you guys have some pretty good familiarity with it. If not, this is just extra practice. But 6 times 4. It gives me 24. And the square root of 4 is 2. So now, we know that the square root of -1 is I. And then this is just kind of a notation-wise, we always write the I in between the real and the radical. So we would call this 2I square root of 6. Now you notice I didn't put a plus and minus in front of this, and the reason why is I didn't put the square root there. I didn't use the square root to simplify a problem. This was just, it is whatever sign. So if this is positive, then the answer is positive. If it was negative, then the answer would be negative. So what if I have a problem like this? 4 plus the square root of -36. Now you'll notice, we can't just grab our calculator, right? That's one of the beauties about this is something you just have to know, because your calculator can't do the square root of -36. So we have to break it down. And we're going to leave that 4 there in a second, and we might deal with it, but I'll show you why it's just a regular number at present. But what do? We don't like that negative. That's the problem today. So we're going to pull that factor out, and then I got square root of 36. Well, that's a friendly number. Will the solution always be written in that format? Yes, and that's something you're going to be seeing today, how the solutions are written. So as we do more and more, you'll start seeing the pattern of how we write those solutions. So we know the square root of 36 is 6. We know that the square root of -1 is I. So how do we write that? We would write this as 6I. Oh, and what did I forget? Plus 4, right? The plus 4 is going to just drop down. Now notice, we cannot add the 4 plus the 6i. 6i is the imaginary solution, and 4 is the real part, so we can't combine the real with the imaginary. But Ava asked this question, is it always going to be written in this format? Yes. Why is that? A complex number is written in the form of a plus bi. And that was one of the first things that you wrote down up top here. So a plus bi, that's the way this number is written, where it's the real portion plus the imaginary portion. And again, we'll do so much of this that you will really become comfortable with it. So what about a problem like this? This looks actually kind of nasty, right? Doesn't look super friendly. However, all it is a complex number divided. by something. So what I would do first is I would set this up as, you know what? This whole thing is divided by 3. So I could rewrite this where each numerator, the 27 and the square root of negative 18, are both divisible by their own 3. And the reason why that's beneficial, 27 divided by 3 is 9, so that's really friendly. And I'm going to do some side work here. I can't divide 3 by the square root of negative 18 yet. I have to break that down like we did with the other two. So think of this as side work. And when you become good at this, you could do this in your head. So how do we think of the square root of negative 18? Well, we take a factor of negative 1L and 18. And now we can break that square root of 18 down. So I'm thinking, what perfect square goes into 18? 9 and 2. And then the square root of 9 is 3. We cannot break down the square root of 2. And we know that that square root of negative 1 is I, but that I is going to go right in between the 3 and the square root of 2. Okay. So, all of this is going to replace the square root of negative 18. Now you could see that we're going to divide this by 3. I'm going to write it out just so you guys can visually see what we're doing. You might be able to skip this step if you know what we're doing. So now notice, I have a 3i. Well, that 3 is a multiplier. And that 3 is going to be divided by that 3. So all that's left over is 9 minus I square root of 2. And that is my final answer. And the reason why is this is kind of written in the form of an a plus bi. Or a minus in this case instead of plus. But it still meets the criteria of a complex number. Okay. So notice the directions. This was just simplifying. We didn't really do any operations. We're just teaching you, if you got an answer that looked like one of these, this is how you would simplify. Well, since complex numbers are kind of like a new set of numbers to us, they should and have to follow operations. How do you add, subtract, and multiply? We're not going to look into divide, but how do we do operations with them? Don't write this down. This is just helping you guys kind of look at your journey through life, right? When we were wee little ones, what did you start doing? 1, 2, 3, 4. You know, start counting, right? That's how my little daughter starts to count. So you look at the natural numbers, or the counting numbers. And then 0 came into play, and those were the set of all the whole numbers, right? 0 all the way up to as high as you can count. But then somebody said, well, wait a minute. What about the negative numbers? Right? You got negative numbers that also include positive numbers, and those were the set of all integers. But then somebody said, well, what about the numbers in between them? Those were decimals or fractions, and that's what rational, kind of running down the highlighted numbers. But those are rational numbers, so anything that is basically a number that's in between these, that is a friendly terminating decimal, like 0.75 or 0.333 repeating. And then we had irrational numbers. Hopefully you just celebrated Pi Day the other day, 3.1415928, and it just keeps going on and on and on, but it never repeats. So that's what an irrational number is, and examples are like the square root of 2, square root of 3, and so on. But all of these are encompassed in what we call the real number system. Well, today, we're expanding ourselves out of the real number system into imaginary numbers. And imaginary numbers are examples like 3 plus I, or 24i. right? Or maybe it's negative 24. Anytime you see that I, which we know where it came from, those are called imaginary numbers. And then complex numbers are what happens when you take the real part plus the imaginary part, or the real minus the imaginary. Now here's the nice thing. This is just helping you frame your thought. I'm never going to test you on name an integer that's between this and that. Like, you don't have to really know that, so don't worry about it. I just wanted to help paint the picture of what you've learned, and notice we're branching out of this real number system into a different journey. Okay, so I don't know if you want to write all of these down. Actually, what I'll have you do is don't write this first one, and then maybe I'll have you write these two here just because you can see how they're done. So, I'll do this one really quick just so you guys can see. How is this set up? Well, I've got a number here, a complex number. It's got the real part, and it has the imaginary part. So that's the A minus BI. And then I'm adding that to another complex number. But notice, this complex number has a real part plus an imaginary part. Well, real numbers can be added together, and complex numbers, or imaginary numbers can be added together. So what we're going to do is we're going to take the two real parts and add those together, and then we're going to take the two imaginary parts and add those together, and that will be my final answer. Because what is 12 plus negative 8? That's 4. Negative 11 plus 3, actually, I don't need that plus there because negative 11 plus 3i is going to be negative 8i, or minus 8i. And then here's my form, a minus bi. So that's how we add the complex numbers. It's similar to the way you add arithmetic with square roots. You can only combine like terms. So real plus real, imaginary plus imaginary. So let's go ahead and write this middle one, just so you have an example in your notes. The trick with this one is it looks a little bit different than what we have, but we have real parts and imaginary parts being added together. But there's one trick that is often overlooked. And it's usually the biggest mistake students make in one of them in math all around. They forget about negatives. I have 35 minus this entire complex number. The first thing you're going to do is you're going to distribute that negative. So I'll really think of this as 35 minus 13, and then the negative 4i turns into a positive 4i. And now, look at the format. It's already set up where you have the real parts grouped together, and you have the imaginary parts grouped together, so you can just kind of think of, well, those are my real numbers, and those are my imaginary numbers. And then you can finish that really quick. You get 22 plus 6i. So there's, look at the format, a plus bi. That's my real, or the real part plus the imaginary part. So it fits that mold of what we call the complex number. All right. Basically, same thing here. Why don't you guys try this one? And we'll go over it in just a second. So the trick on this one is very similar to the middle one we just did. That negative sign has to go to every single piece in the parenthesis that comes after it. So we're distributing the negative, which means the first part doesn't change. And then this is going to turn into a minus 24 and a plus 9i. And then you can just think of, okay, 15 minus 24. So what is that? Is that negative 9? And then if I look at negative 9i plus 9i, those are going to add up to 0. So you don't have to write it. Some kids like to write it, just so you could see that that is a real part plus the imaginary part. But, to be honest, the better way to write this is just negative 9. So, that's how we add and subtract complex numbers. You just have to be careful. And it's usually pretty good, because it's kind of just like adding like terms. What happens if we multiply? Definitely write this one down. You're going to see something kind of interesting appear here. And I don't think you have to do it this way. Actually, you know what? Maybe I won't. I'll show you on the next one. What do we do? Well, this is a distributive property. We're going to multiply 8 minus 9i by the number that's on the outside. So I'm going to distribute a negative 5i to 8. Well, negative 5 times 8 is negative 40i. And then negative 5i times negative 9i is a positive 45. And what's I times I? I squared. I squared. Perfect. Now, are we done? What do you want to do right away, or what pops out to you? You see anything, any fun facts that we know?
I squared is negative 1.
There it is. I squared is negative 1. And that's the reason why, if we knew what I was, we can also know what I squared is. We don't need to show the work. But just remember, we know that I squared is equal to negative 1. So I'm going to show probably a little bit more work than you actually need to. But I'm going to replace I squared with negative 1. And then watch how this kind of changes the order of things. Negative 1 times 45 is a negative 45. And then I have the minus 40i. I'm going to put that at the end. And just the only reason why is because it's now in that form of a minus bi. So it's a complex number there, a minus bi. So that's the one thing that you really have to be aware of, is when you see that I squared, which always occurs anytime you multiply I times I, you know that that I squared is going to be replaced with negative 1. All right, last one for this slide. What if I take a complex number times a complex number? Now you could do FOIL, or this is the part where I want to show you, I think I would recommend using the box method on this. This would be the box without the circle, because sometimes people just call this the area model. It doesn't matter which one goes across the top, or which one goes on the left side. But I just like the format of this. Because now it's just multiplying. It's just multiplying 4 times negative 8. So that gives me negative 32. And then I've got 4 times 2, which is 8i. And you can put a positive here because it is a positive number. And then the next box will be negative 7i times 8. Well, that's a positive 56i. And then we've got negative 7i times 2i, so that's negative 14. I times I would be I squared.
You just write
So already, Cam, you're noticing the shortcuts, right? And if you realize that, I'm going to show my work just because not everybody realizes it at the same time. Whoa. There we go. So notice this isn't our answer, right? Our answer has to be written out as, well, negative 32 plus, oh, wait a minute, 56i and 8i. I can actually add those together, and that'll give me 64i. But then as Cam said, can't I just take this fact that we know this has to be equal to negative 1? And I'm showing way too much work right now. But that's just so you guys can see where everything comes from. But I know that I squared is negative 1. And that's going to end up being a positive 14. And then the last piece is we know that negative 32 plus 14, is that 22? No. Negative 18, thank you. And look at that answer. A plus BI. It's written in that complex form. Okay. So, the only thing you have to worry about with multiplication is that fun fact of I squared is equal to negative 1. And you can save as much work as you need to if you can do it in your head. The thing I love about this, a calculator really isn't going to do much help here, because a calculator can't process the i's or the imaginary numbers unless it's a special kind of calculator. All right, so we're shifting gears right now, and we're going to come back to this whole idea of solving. Right? So really, we're going to make a connection to what we did on Monday. The only difference is now we can have imaginary numbers appear. The problem with imaginary solutions is they most likely don't come from a friendly equation. They come from something that can't really be factored like we've done on Monday. So if I tell you to solve this, what's your first step that you're going to do?
Get everything on one side.
Perfect. Get everything over to one side. And my hint, you don't always have to do this, but my hint is to always keep the value with the squared, so the 3r squared. We want to keep that positive or make it positive if it isn't. So that just means you have to move the 6r over to the other side with the addition. And we're at this point right here. Okay. Now, I don't want you guys to waste time and write a whole bunch of notes, but what would you try to do next?
Take the 10 unit, add it to the other side.
Well, so notice how we have an r squared here, and we have a different term r. So if we just had r squared, you can combine them and use algebra and solve. But like we saw on Monday, when I have an r squared and an r, we can't just do regular algebra. We have to rely on something else. Factoring, right? Now, don't write this, because I will just tell you it's not going to work. And that's where we're going, is what happens with factoring doesn't. But let's say that I just didn't know that, and if we had more time today, I would have actually had you guys try this and watch you struggle through it. Kind of cruel, but it's also fun for me. So what would we try to do? And again, those of you at home, don't write this. But what would we do? We multiply the corners, and I'd get factors. I'd look for factors of negative 30r squared that have to add up to 4. Well, right away I'm thinking, well, 1 and 30, 2 and 15, 3 and 10, but none of them are 4 units apart. And one of them could be negative. We don't know if it's the first one or the second. But then I get kind of stuck, and the only other factors are 5 and 6. And it doesn't matter if the 5 is negative or the 6 is negative. None of them are 4 units apart. And that happens often. So what happens when factoring is not an option? What happens if I cannot factor? Do we have another method? And that's where today's second lesson comes in. You may remember this, but the quadratic formula. So I apologize, I didn't realize this was as small as it is. Let's see if I can make it bigger for us. But I would write this part here. There we go. And you may have, hopefully, good memories of the quadratic formula. We even get to sing a song today. I apologize for you guys in person because you actually get to hear me sing live. There are a couple of steps that have to be true for us to use the quadratic formula. And it's kind of been true when we did factoring too. So the first step should be something we're really comfortable with, is the equation must be in standard form. And all that means is you have to set it equal to 0, just like Ham suggested in our first step. Solve, move everything over to one side, and then you can identify what the A, B, and C are. A is always going to be the number that's in front of the squared value. So I might actually use different coloring here. So in our example, our A is the 3, because that's attached to the R squared. The B value is the number in front of the single variable. So in this case, what's in front of the R is the 4. And then the last one, the C value, is going to be the single constant. The reason, in my mind, the reason why we call it C stands for constant. And the negative 10, notice how I'm including that negative, the negative 10 is the constant. So, that is a very important step. You cannot do step 2. You cannot determine A, B, and C until it's written in standard form, until the equation is equal to 0. And then comes the fun part. I would recommend memorizing this formula. Now, you know that when we do tests and quizzes, they're going to be on Fridays. And I can't control one way or the other if you're at home using your notes or not. So I'm going to tell you to use your notes just to make sure that things are accurate. Because that's what we want you to do. So hopefully you're taking good notes. And the quadratic formula is kind of a complicated looking formula. But once you get the hang of it, it's really friendly. So, you ready to sing? You don't have to sing if you don't want to. You know the song to Pop Goes the Weasel? That's what this is. So, x is equal to opposite b plus or minus the square root b squared minus 4ac all over 2a. Sounds silly. Mr. Stutzman, if you know him, he actually had his son, who's now a senior at North. When he was 2 years old, he was singing that song. He would probably not be happy if he knew that I was sharing that. So then what do? Once we plug in A, B, and C, we just simplify. And the big part is using this idea of order of operations. So you have to know how to simplify correctly. And this is something that I'm going to actually encourage you to not fully use your calculator on, because it actually makes it harder to do. So let's take our example. You know what A, B, and C are. Now we're going to plug it in. I like to use different colors, especially when teaching. And I'll show you how I set this stuff up. So I look at the formula, and anywhere there's a letter, that's what I'm going to substitute in. So everything else in my mind is just written in a standard color. But then opposite of B, the first part, well, if B is 4, the opposite of B is -4. And then B squared, I'm just going to literally type in 4. Doesn't look great. That's a 4 there. And then I've got -4 times A. Well, what was A? A was 3, and C is -10. All divided by 2 times A. So my first step, all written in blue, is just substitution. Plug in what you know A, B, and C are. And then I'm going to simplify. Now, the part that is underneath this square root is called the discriminant. And you may have heard that term before. We'll talk about this idea of a discriminant, but it's going to come up a lot more when we start graphing parabolas. So what does this middle part do? Well, here's what I would do. I know 4 squared is 16. And then I'm going to take the next part. I'm going to treat this as a -4. So -4 times 3 is -12. And -12 times -10 is a positive 120. All over 2 times 3, which is 6. So notice how my blue and red, that's the new step. That's where I simplified. And you could honestly just add that to save a step. Some of you that are really well versed in this will realize there's areas that you can skip showing somewhat. Okay, now, here's the part where I don't want you to just grab a calculator, even though that's just what I did. I'm not looking for decimal answers. I want reduced fractions. So what we have to do is think of this as side work. I got to reduce that square root of 136. So I'm going to do that on the side, and I'm going to just take 136 and see what is it divisible by. Well, I know 4 goes into it, as my calculator told me. 4 times 34. And then I know that 34 is 2 times 17, and that doesn't break down. So I'm really just thinking of it as square root of 4 times the square root of 34, which is 2 square roots of 34. So that is what the radical reduces down to. So notice how we're building, we're throwing those pieces in from geometry, just to make this easier. And then I'm going to do something kind of unique here, and let's see if you guys are comfortable with this. So remember how we were dividing by 3 in that other example? Here we're dividing by 6. Let's just rewrite this. So each piece is divided by its own 6. And the reason why I would do that is now I've got -4 over 6, which reduces down to 2/3. And then I have a plus minus. And we'll talk about where that plus minus comes into play. But then I've got 2 divided by 6. Well, this 2 and this 6 can reduce down to 1/3. So see how the 2 over 6 turned into 1/3? And then the square root of 34, that's a radical number, so that's protected. It's not going to be reduced down by the 6 at all. Now officially, these are my answers. And I say there's answers because there's 2 of them. But it is important just to understand that there's one answer where I use the plus version. And by the way, see how I didn't write the 1 in front of the square root of 34? you don't have to write the 1, because 1 times anything is still 1. So there's one answer using the plus, and the other answer would be using the subtraction. Now, the only thing we really used our calculator for was just to look at the factors. Everything else was done without a calculator, and I want you to be aware that that's what we expect from you. Okay, so try not to just grab a calculator. Decimal answers are not what we're looking for here. Let's see. What I'd like to do is I'm going to give you guys about 6 minutes to see how far you can get on these two problems. And I'll just tell you right away, we're going to use the quadratic formula on them. Okay? And also make sure that you first do the first step, which is making it equal to 0. And then we'll go over them in a couple of minutes. Let me know if you guys have any questions. All right. So if you correctly identify what A, B, and C are, then we can plug them in. So we had B is 2, so opposite of 2 is negative 2. And then just plug all the other values in. And then we'll simplify it. Now this is the part where underneath the square root, that thing that I called the discriminant, which we'll talk more about, you can do this in your head if you want, or you can go to side work, because I don't want to keep writing it in. But I know I've got a 4 here. So a 4, and then negative 4 times 2 is negative 8. Negative 8 times 5 is negative 40. So I end up with a 4 minus 40, or a negative 36. Okay. And then I can break the square root. So again, I'm doing side work here. I'm thinking, how do I deal with this negative square root of 36? Well, wait a minute. We don't like the negative, so we're going to pull that out. And that's actually going to be one of our imaginary numbers. So the square root of 36 is 6. And then I becomes the square root of negative 1. So the whole square root of negative 36. ends up being 6i. All right, and then I would actually prefer to write this as, instead of -2 plus minus 6i, all divided by 4, divide them by each by 4, because then I can simplify. So I'll get -1/2 plus minus 3/2 I. And sometimes the I is written next to the 3, sometimes it's written on the outside. It doesn't matter. And those are my two answers. You don't have to write them separately if you put the plus and minus there, and just understand that those are two different answers. That was better? All right. Well, let's see if I did this one right. So first step in example 3 is to move over the two pieces. Now, I like to keep the x squared positive. It doesn't matter. If you moved it to the other side, all of your values will be the opposite sign. So you'll get a little bit different work, but the answer will end up to be the same. So it doesn't really matter which way you move everything. And then when I plug in the items, I'm going to make this bigger because it's a little small. There we go. So I'm just going to double check my work because I don't trust myself anymore. Opposite of b is -3. 3 squared minus a times c all over 2a. So that's good. And then simplify, we get 9 minus 56. And then I know that 9 minus 56 is -47. So now I'm looking at, how do I simplify the square root of -47? Well, 47 is a prime number, or no perfect squares go into it. So I'm just going to pull the -1 out and call that I square root of 47. And then for some reason I decided to write this one as two separate answers instead of using the plus minus. But notice both of these examples are imaginary numbers because they both have a square root of a negative. Anytime the discriminant is negative, you know your answer is going to have an I in it, an imaginary number. So once you really get the hang of this, it's not bad. Although, as I've displayed, you can make small mistakes, and that'll screw everything up, right? So I'm actually kind of glad that happened. A little embarrassed, but I'm glad. I'm sure you guys are used to my small mistakes all the time on Zoom. So, all right. So here's what we got tonight. Our homework is Delta Math. It's titled Complex Numbers and Quadratic Formula. It's from sections 4.6 and 4.8. Those of you coming back to, well, those of you in class, you'll come back. You'll be able to work on that this afternoon. If you're on Zoom and you have any questions, feel free to come back today at 12:15. Just use our class link, and I'll be on here, and I can help you out with any questions you got. And the other thing I just want to mention is we do have a quiz on Friday, and it's going to cover factoring and solving, and then what we did today, complex numbers and quadratic formula. Okay. Now, this last little piece, I'll let you know, the quadratic formula works for anything. So even if it can be factored, you can still use the quadratic formula to get your answer. But it is important that we know how to both factor, and if factoring doesn't work, then you can use quadratic formula. So that's all I got. Have a great day. Adios to everybody on Zoom. I'm going to bring the desk up here quick, so stand up and relax. If you don't have an Algebra 2 textbook, before you leave today, just go to the Media Center and just say, I got to check out a book, and they'll give you one there.
Okay.
All right.
I was just about to ask about that.
Yeah, we can even do that this afternoon, too, in class. I'll just take whoever needs it. You can go there and get it if you haven't had a chance to stop by.
Okay.
Have a good day. Yep.
You too.
Yep. Noah, you there?
Yeah.
Okay. I just want to make sure. I got to log off here, so I just sprayed the desks, so we're going to let it sit for a minute or two. So, see you, Noah. Have a good one.
Yep, you too.
Thank you.
Still waiting on our call.
Yeah. Actually, anytime, like a couple minutes go by or an hour or so and I haven't heard anything, and I'm like, shoot, is my ringer on? And I double check, even though I know it's on, and I've checked it like 3 times today.
Yeah.
I think it's just that nerves of like,
Yeah.
am I ready for this? I will say, if this was my first child, I'd be freaking out.
Yeah.
Luckily, I kind of know what to expect. Hopefully, everything goes well. 5th hour. Hello. So I just sprayed the desks maybe a couple minutes ago. We're just going to let them sit for another minute, and then I'll wipe them down and let you guys know where, I guess let you know where you sit too. Hello. Hang tight. I just sprayed the desk down a little bit, so maybe a couple of minutes. We're going to let them sit for another minute, and then I'll tell you where your seats are.